What's up guys, Eric with Verus Engineering. I'm joined with Paul Lucas. Paul started with us 10 years ago now, and he was our head aerodynamicist, and he basically really ran some high-end projects that we're kind of known for today. And rewind 2 or 3 years, we didn't have a marketing guy to really talk about this and go on vlogs and talk about what we did, how we did it, and all that type of stuff, but now we do.
So it originally started off as we were just gonna do like an Aero package, so splitter, maybe a diffuser and a rear wing. And that quickly tumbled into something a lot more. So we ended up doing the entire car, including bodywork, fender liners, heat exchanger ducting, basically everything you see on the car that is carbon fiber, we designed. The entire exterior of the car was done minus the doors and the roof. Everything else.
Yeah, and like half of the C-pillar, half of the A-pillar, or the full A-pillar.
Yes.
Whatever time attack.
The pillars.
Yeah. Whatever Pikes Peak's rules are, that was basically all that stayed.
Yeah.
Everything else
else was custom. And yeah, so it was it quickly went from, oh, this is totally achievable by the time period that they wanted to, oh wow, this is a ton of work to get done in a very short amount of time.
Yeah, so what a lot of people don't actually realize is that this actually started, I think, the same year that they ran it. So
Yeah.
it's like in January.
Yeah, beginning of, well, they hinted that they were talking about a project in December. And then we finally started working on it and getting the scope of the project in January.
And by the way, that also means that Scarbo, who was also working on this project, and BBI, who was also working on this project, had nothing done. So chassis was non-existent besides the external of the car. And then the engine and the drivetrain was also non-existent from BBI standpoint. So simultaneously, Scarbo, Paul, and BBI are developing this project and sharing data continuously for the next, what was it, 5 months?
Yeah.
Basically
we didn't finish everything until basically a few weeks, or actually a few days before they'd go to the mountain.
Yeah.
For testing.
So that's like something that a lot of people actually don't know, and nobody really actually talked about that. That was like a crazy part of the project, was the lack of time and how much actually did get done when there is no, well, we can just push it back. No, you can't push it back. I mean, we were pushing molds like the first few weeks.
Yeah, so we started off as early on, the first thing we started to have was bits and pieces of the front chassis. We had an idea of the size of the cooler we needed, so they ended up running the same size like radiator setup that they ran previously, and I believe Lucy. And so we had that, so we started with the inlet and exit ducting of the heat exchanger, so the radiator in the front. But we didn't really have the hood or the bumper designed. So the hood and the bumper were designed around the ducting, because the ducting was the first thing we actually did, because it's the first thing we could do. And then so on the Aero process, it kind of started its way from the front to the back. So we were just running analysis on, say, a front splitter for a long time with kind of a body shape that somewhat looks like a car, and was running that to kind of improve and do things until a lot of the back half of the car was done, and we could kind of start testing really closer to what the actual end product would be. The fender liner was insane.
The fender liner, the pylons behind the wheels, like,
oh, yeah.
that was like add-on because you found out that it was like absolutely garbage airflow, and you're like, how do I fix this?
Yeah.
And you figured out how to fix it, and then you had to like talk with Robin about how to actually manufacture the thing, because it was like impossible to manufacture.
Yeah, so one of the parts of the car is it's obviously really wide. It's wider than it is long. Not really, but it kind of looks like that. It's really fat. It's like a tuna can going down.
Pig.
And yeah, pig.
Piggy.
Yeah, I guess that makes sense. Yeah, it's wider than it is long. And so the front tires were open behind it, which normally wouldn't be a huge deal. You see that a lot in time attack car where they cut the fender to get more airflow evacuated, which totally makes sense until you have a tire that's like 1.5 feet wide in the front, completely open. I think it was actually 18 inches from the outside tire to the actual door is how far it sat out on the side, which actually causes all kinds of problems. And the reason it was so bad is because we were originally going to try to actually put coolers back in front of the rear tires. And probably about 4 months into it, we found there actually wasn't enough room for any of that. So we had to come up with another solution. But there was also really terrible airflow off that front tire. And there's really nothing there to condition it because there was nothing there. So we had to come up with a cool solution, and that's what I don't even know what you'd call that.
A barge board
Yeah,
or something.
Circular airfoil, barge board. I guess it's more like an upside down U, lowercase n shape, but an airfoil that kind of cleans up the airflow off the tire and pushes it outboard, so it creates outwash. Because you want to push as much terrible airflow out so it doesn't affect the rest of the car. Because if you have it go down the side of the car, it's going to get sucked back underneath the floor, tear up the diffuser, not tear it up, but bad flow. Also affects the wing because you have big fenders in the rear, so it's going to direct airflow over that into the wing. So it kind of creates all kinds of problems. So yeah, that was a complicated problem to solve. Not the worst problem. Worst problem is actually the windshield angle.
Yeah, that was one thing that I remember you just complaining about constantly.
Yeah, so with an old Porsche, the windshield's like sunk in and it's got this big rubber grommet around it like all old cars do. And since the windshield angle's so terrible on that, with those two things, it actually separates airflow off the roof, which means to actually get good flow to the wing would have to be at least a foot taller than the roof, like the main element. And there's two elements, which then it would just look like you're running a billboard in the back of the car, which was really silly looking, and no one wants an ugly looking car. So we had to figure out a way to solve that. And we actually just came up with a really simple solution. They made actually some brackets, and we found out that if you actually just push the windshield out, so basically the windshield was sunk in and it had like this lip, and they just kind of like pushed it out, and we tested that, and that actually solved the problem. But that took probably like 20 CFD analysis to kind of like figure out if that would actually work or not.
Something else that was really interesting about this project that we hadn't done in the past was work with another company, Oil Stain Labs, and actually do a render to then CFD to then back to render to CFD iterative process, because we didn't know who it was who owned the car at the time. I don't even know who's actually making the physical appearance decisions. But anyways, this person actually cared about what the car really looked like, which is totally understandable. So we basically used somebody who did renders, and we worked with them to ensure that what the people wanted the car to look like, who I'm assuming is Mobile One or Ken Block, I don't know. But whatever they wanted it to look like, could have been Tim for all I know. I don't know. Whoever wanted the car to look a specific way, they wanted it to look a specific way, and then Paul had to make sure that it worked. And it was an iterative process going back and forth, because sometimes Oil Stain Lab would come up with what they wanted it to look like, and it would be absolutely terrible for airflow, and we needed to blend that function and form really well. And sometimes they also helped you with surfacing, which was kind of cool too.
So if you think of it like how the automotive world works, you have what's called designers, and then you would have like an aerodynamicist, and they were like the designers. So they come up with the concept, because realistically, engineers aren't really that good usually at creating good-looking things.
Cosmetics.
Yeah.
Yeah.
And I'm notoriously really bad at that. So if it was my choice to design 100% of the Hoonipig, most people would have been like, oh, that thing's really ugly. So they kind of made it look good, and then I took that looking good and tried to make it work, and then we'd go back and forth, because there'd be certain aspects of it that's just we couldn't incorporate, or it wouldn't be making enough downforce. So we had to come up with creative solutions to kind of keep that same look that they were going for, but actually make it work. And not everybody was happy with all of the final product because of the timeline. There were certain things that we kind of just had to just get done. but that's part of it because we only had less than 5 months to do the whole thing. We had over 100 parts. I think it was like 120 something parts that we physically designed and manufactured just on the Aero kit. And there's some parts that like I would change doing it again, like the floor. Floor was a disaster. Not like performance-wise, but not the manufacturing. Not because he didn't do anything. Like the guys who made it did a great job. It's just actually the thought of how you would do it in the computer and being like, oh yeah, this is a really good idea. And then you get there to actually install it, because we helped build the car too. It was like, oh man, this was really stupid. Why'd I do this?
Yeah.
And good learning experience of
Definitely
what not to do.
Yeah, so in May of that year, Batim and Dimitri invited us out to go help put the car together. So we took the opportunity to fly out there and build the car for 5 days. One of Hoonigan Racing guys came too, which was kind of cool to meet him because he puts together the WRC, WRX cars and the rally cars. And me and Paul are like fighting putting this stuff together because we're used to OEM cars. We want OEM fit. We were always like, everything has to fit perfectly. And then we get there and everything is being like trimmed to fit. Everything is kind of like going together, not hodgepodge, but just like you have to trim literally every piece to get it to fit well. And the Hoonigan guy comes in like 3 days in, and he's like, these pieces fit amazing. This is awesome. Who does your carbon work? We're like, this is garbage.
Yeah, because
it was like very perspective.
Yeah.
Like his perspective was it's awesome. Our perspective was it's crap. And that's just kind of how race cars go.
Yeah, because we were, like, you take an OEM part from a car, like you, say somebody smashes your fender, and you buy a new fender from X manufacturer that's OEM, and you put it on your car. You unbolt yours, you bolt the new one in, it lines up perfectly, there's nothing that needs to be done, it just fits. That's not how carbon parts work on a big car.
No.
Like, unless you're doing like big money stuff like aluminum molds and stuff like that, where you don't have parts that kind of tweak when they get pulled out of the mold and stuff like that. It is almost impossible to make something fit OEM quality with carbon, at least in that amount of time with that much money spent, because realistically everything was done. It's impressive they were able to get any of the carbon work done, because everything was
super last minute,
all one-off. Everything was 3D. The front end plates were 3D. The rear end plates were 3D. We had, oh yeah, this was also in the middle of COVID. So because I know he had an issue getting carbon.
Yeah, supply chain was a big issue after COVID. So Yeah,
because it was right after the Russian invasion, because he was talking about he was having a hard time getting carbon because they're in Europe.
Yep.
And there was an issue. They were thinking Russia was going to invade other places, and then there was a shortage of carbon, and we might have had to get carbon in the U.S. and send over there because these guys were in Sweden. All kinds of craziness.
Also, to point on that, like we've actually interviewed guys from Chip Ganassi and IndyCar teams, and they have dedicated people to trimming and fitting carbon for Indy cars. So this isn't just like, oh man, they just hodgepodge this together. No, Indy cars have to be trimmed to fit and actually fit well. And they actually have each piece that goes on the car, just because it fits on one car, it doesn't even fit on the next car. So I don't know. All I'm saying is that carbon is a little bit of a fickle pickle when it comes to manufacturing goes.
How to manufacture certain things, so it's easy to work on. And then just thinking of getting a better aspect of different groups of people who are working on the car and the trackside support, and how I would focus on some of the manufacturing involved. Specifically, the floor being 5 pieces seemed like a really good idea, so you could work on different aspects, but it made it really hard to work on, and you couldn't actually just take one part off, so it ended up being 2 pieces, even though it was 5, which I think 2 pieces would have been a much better designed kit. Focus less on, oh, how well does this fit together, 1 or 2 millimeters, because once you actually build the car, 1 to 2 millimeters doesn't mean anything. Just tape up gaps if there's a gap or something like that. Think of the big picture and don't focus on little details, which is sometimes difficult when you're looking at parts on the computer. Things that I thought that worked really well, I thought was the fender liners actually turned out much better than I was expecting.
Those were like one of my favorite parts.
Yeah, because I don't want to say half-assed, but it was the very last parts I worked on, and I kind of just slapped some surfaces in there and some bosses and kind of hoped it worked, and they actually fit better than probably, like the floor I spent 10 times longer on, and it turned out way worse than the fender liners that I spent way less time on. They were awesome, and Kevlar looks really cool in fender liners too. That's another cool takeaway.
It was very cool.
My favorite part of it was actually the front wing splitter. I like the 3-element on the side. So the goal of that was to kind of somewhat look like the rendering. They had this triple element looking canard setup, dive plane setup on the side. So we were able to kind of replicate that design with the 3 elements, and just how they adjusted all together, how it got put together, how well it works even with the splitter on the ground. So specifically how it's designed is a lot of times when you think of like an element, like with a rear wing, the second element gets its airflow from the bottom and the top side of the main element. Whereas this, if the splitter touches the ground with how it's designed, it can get all the airflow from just the top side alone. And so you would still, so you don't lose all your downforce when the splitter would touch the ground. And because of that, the outside was designed lower than the inside. So if the splitter fully touched the ground, none of the whole splitter fully stalled out because the center was still high up where the diffusers were, and then the winglets on the side actually still kept downforce out on the corner. So I thought that was the coolest part, me personally.